All right, so section 4, part 1 is evaluating limits algebraically. So there's always some kind of method, instead of using a graph and table, like a way that we can figure out, well, not always, but usually there is a method that we can figure out what the limits are. Sometimes you do have to kind of graph it. All right, so we're going to start out with the limit laws. Limit laws are super simple. I'm not going to spend very long on these at all. Basically, with limit laws, it says that if you have a sum, you can bring the limit part into both parts of the sum. If you have a product, you can bring the limit part into both parts of the product. Quotient and so on, as long as the bottom isn't equal to 0. You can pull constants to the front. It's basically anything that you would think that you can do, like with your normal rules of distributive property and so on. It works the same way with limits, okay? So I could give you a very complicated thing and ask you to solve it using limit laws. So we'll see what it looks like graphically. So I have two graphs. I have f of x and I have g of x. And we're going to use these graphs and the limit laws to figure out what all of these are. So you might have something like this on the AP test where it gives you a graph and you have to figure out what's happening. So if I have the limit as x goes to -2 of f of x plus 5g of x, I'm first going to realize that what that's asking is the limit as x goes to -2 of f of x plus 5 times the limit as x goes to -2 of g of x. It looks like that. Does that make sense? It's pretty basic. I used to spend like seriously 20 minutes just talking about limit laws, and I was like, no, it's pretty basic. All right, so anyway, so if I have the limit as x goes to -2 of f of x, do we know what that is? What y value do I get closer and closer to? 3. And I have plus 5 times the limit as x goes to -2 for g of x. So now we look at the g of x graph. So as I go towards -2, what do I get closer and closer to? 2. So I have 3 plus 10, which is a total of 13. Do we understand that? Good. All right, so the limit as x goes to 1. So I'm going to do the limit as x goes to 1 of f of x times the limit as x goes to 1 of g of x. So the limit as x goes to 1, for f of x, it's 2. The limit as x goes to 1 for g of x is 0. 2 times 0 then is 0. Done. You guys having trouble writing the limit? It's weird to write limit, limit, limit each time. I told one of my students a long time ago that they could just write L squiggle, and then I would just know that they were writing limit every single time. And then he said that he did it on the AP test, and I was like, okay, I will never tell my students they can write L squiggle again. You really should write limit with the numbers underneath. All right, so limit as x goes to 3 of f of x over g of x. So that is the limit goes into both of them. So it's the limit as x goes to 3 of f of x over the limit as x goes to 3 of g of x. And we find each of them. So the limit as x goes to 3 for f of x, what number? 1. How about g of x? 2. So I have 1 over 2, so 1/2. Do you hope that your entire test is like this? Yeah. Would that be nice? All right, so how about this one? So limit as x goes to 0 of 2 f of x. So we're going to pull the 2 out, and we're going to say the limit as x goes to 0 of f of x plus the, well, I'm going to pull the 3 out, so 3 times the limit as x goes to 0 of g of x. All right, so I get 2 times limit as f of x goes to 0. Ah, does not exist, right? D and E. So what do we write for the whole thing? Does not exist, because this part right here did not exist. So we don't have to do the rest of the problem. We just say D.
It does not exist because there's like 2.
Yeah, because you have to go from both the left and the right, and since the left limit and the right limit are not the same, it does not exist. All right, so how about the next one? So we're going to have 2 times the limit as x goes to 5 of f of x plus 3 times the limit as x goes to 5 of g of x. So as we go towards 5 on f of x, what do we go towards? And as we go towards 5 on g of x, I think 1, 2, 3, 4, 5. 4. So we have 6 plus 12, so we get a total of 18. All right, so that's how limit laws work. You can pull things in, find the limits of each individual function. All right, so there are more limit laws. Did I skip some? Do you guys have more on your page? All right, I don't know. All right, so basically if I have the limit as x goes to a of x to the n, I could just do the limit as x goes to a of x, and then I can take that to the n. Okay, now what does that mean? What if I had the limit as x goes to 5 of x? What do you think it is? I think that was one of the ones above there, wasn't it? I think I did get cut off. Yeah, 6 and 7 were cut off. All right, 6, 7, and 8. All right, so let's do number 6. So number 6 says the limit as x goes to a of f of x, whoa, it's moving, of f of x raised to the n is going to be the limit as x goes to a of f of x, and then it's all going to be raised to the n. So you can pull the limit inside of that. And then number 7 says the limit as x goes to a for some constant, a c value, it's just equal to whatever c is. That might be confusing, but if you think about the graph of y equals c, it looks like this. So as you go towards a certain a value, aren't you always along the line y equals c? The y value is always c. So there's nothing to plug in for x. And then if I have the limit as x goes to a of just x, well, what does the line y equal x look like? It looks like this. So as I go towards a certain a value, what point is right here? A, right? A comma A. Does that make sense? So I'd have like 1, 1, 2, 2, 3, 3, 4, 4 on that line. So I just get A. It's just a direct substitution. You're plugging in the x or the A value into your x. All right, so the limit as x goes to a of x to the n, the first step is to think about, okay, well, I'm going to distribute the limit in, but then we just did limit law number 8, which says it's just a, so it's a to the n. So basically, there's nothing that's making this undefined. We just plug the number right in for x. All right, so same thing here. This will end up being the nth root of a, and so on. So don't panic about the limit laws. We'll be doing so much with limits that you'll be doing the limit laws without realizing that you're doing the limit laws. So we do a lot of them. All right, so it says evaluate the following limit and justify each step using limit laws. Okay, so it's kind of annoying. All right, so if you're justifying every single step, you would first bring the limit into both pieces, the numerator and denominator. So let me do the first couple steps. I don't know if I want to do all of it. Like that. So you bring it into the quotient, and then you would bring it into the sum, right? So you bring each limit in, and then you break it apart. All right, what ends up happening for this one is you can actually just plug in -2. What happens when you plug in -2? What do we get on the numerator and the denominator? -8 minus 9 over 6 minus 3 times -2. We end up getting -17 over 12. Okay, so I could do like all the limit things where I'm bringing the limit into each piece, I'm substituting in, and so on. It would take a very long time for me to write this. I'm just going to skip it. You would get 17 over 12. Okay? Is it negative? Yes, thank you. All right. Isabeth gets it. Didn't someone else get one earlier too? Okay. All right.
So how does it convert though to like?
What do you mean?
Like how do you get it to go from that just to being like one that you got like?
We won't waste a lot of time on it. I can show you after class if you want. Yeah.
Does it always work that you could just plug?
I don't know. Does it? Do we think it always works where we can just plug in? No. So what would be an example of one that would not work if we could, like if we couldn't plug something in?
It does not exist.
Yeah, if it doesn't exist. So there have to be these other ways to solve this using other things, okay? So that's what we're going to do. So it says, no, if we had just substituted -2 into the original function, we would have obtained the answer. This is because -2 is in the domain. So as long as it's in the domain, it doesn't make it undefined, then we're good. So that's called the direct substitution property. So if f is a polynomial or rational function and a is in the domain, then when you do the limit as you go towards a certain a value of f of x, it's the same as if you just plug in that a value. So you just take whatever your x value is and you plug it in. So you could not use it if we just said the limit as x goes to 2 because 2 gives you an undefined. So plugging into gives undefined. All right, so let's try some examples. So what do we think we're going to do for something like this? Can we plug in -3? We can't plug in -3, right? So what do? We factor. So we say the limit as x goes to -3. We factor into x plus 3 times x minus 3 over x plus 3. And we reduce it out. So the x plus 3's cancel. Now that they've canceled, now can we plug in -3? Yeah, what do we get when we plug in -3? Yeah, -3 minus 3, which is -6. That is the answer. So basically there's a hole there, but there is still a limit. So what if we have cotangent? All right, well, cotangent is cosine over sine. So we have the limit as x goes towards pi over 2 from the left, and we have cosine of x over sine of x. What is the sine of pi over 2? It's 1. Is that one undefined on the bottom? It is not, so it's in the domain. So that means that we can plug in pi over 2. What's cosine of pi over 2? 0. This answer is just 0. It wasn't undefined or anything. It worked out. It was 0. So since it was in the domain, we could plug in. Does that make sense? If you had tangent, I would do like a graph or something. Yeah.
When do you substitute versus just like doing?
If you can plug it in, then plug it in. If you can't plug it in, you got to do a trick. So if you get undefined, then you can't plug it in. All right, so it says if f of x equals g of x, then, except possibly at the single point, then the limits are equal to each other as well. So the drawing for this would be like, you know, you have an f of x curve and you have a g of x curve, except maybe there's an open circle on g of x that has you there. Right, so as long as it's always equal except at that single point, then their limits are also the same. Okay, so what are the methods? So our methods are going to be FOIL, factoring, multiplying by conjugates, and finding common denominators. So this first one, we're going to think about what the graph looks like. So the question is, find the limit as x goes to 1, and it says we have the graph y equals x minus 2. So we're going to graph that. We know what that looks like. Except at x equals 1. So it looks like the line y equals x minus 2, except at the single point x equals 1. So at x equals 1, it says we have 1, 5. This is what this graph looks like. Can you guys all graph that? You remember piecewise functions? So then what is the limit as x goes to 1 then? What y value do you get closer and closer to? Yep, you get closer and closer to -1. So basically you ignore that single point. We don't worry about that single point. It has nothing to do with the limit. Okay, we only look at the other graph. All right, so maybe you have to simplify. So right now on number 2, what happens when you plug in 0 over 0? You get 0 over 0, right? If I plug in h equals 0. So I'm not able to just do a direct substitution. I can't plug 0 in. I have to do some kind of trick. So I think most of you guys just kind of have it ingrained in your head like, hey, when I see 2 minus h squared, I'm going to FOIL that out, right? That's what we're going to do. We're going to FOIL it out. So do 2 minus h times 2 minus h. So we get 4 minus 4h plus h squared minus 4 all over h. And part of it goes away. See how the 4 minus 4 goes away? We're trying to remove the part that made it undefined. See how I can pull an h out? I have -4 plus h all over h. Do you understand what we're doing? This gets rid of the part that made it undefined. The 0 over 0 is now gone because I canceled that. Now are you able to plug in 0 without getting undefined? Yeah. So when you plug in 0, what's our answer? negative 4, right? If I plug in 0 for h, I get negative 4 plus 0, negative 4. So that's the whole point. We try to do something so that we don't have undefined. All right, so let's try the next one. So factoring. I think you guys would probably know how to do these ones too, right? So we're going to factor. So we say the limit as x goes to 4, we factor the top, and we factor, well, the bottom is still just x minus 4, right? I'm guessing it probably has an x minus 4 in it. So if I'm factoring, I would start out x minus 4 and then x minus 2. The x minus 4 goes away, which was the part that was making it 0 over 0. Are you able to plug in a 4 now? Yep, you can plug in a 4, so you get 4 minus 2, which is 2. Okay. We might also have the sum or difference of 2 cubes. Do you guys remember your formula? The SOAP formula, we did it the other day. If you don't know it, I would go back and review. So we're going to have the limit as x goes to 2, and we factor. It's the difference of 2 cubes. So we're going to do x minus 2, and then we have a trinomial. So we're going to have x squared, and 2 times 2 on the end is 4. See how that's giving us kind of what we want at the beginning? We have x cubed, and we have minus 8 at the end. But we want for all those outer and inner terms to cancel, so we actually do need another term in the middle.
Yeah.
Yep, we do 2x. And our signs are same, opposite, always positive. So divided by x minus 2. Cancel, cancel. I put one like this on the test before, and people missed it just because they didn't know how to factor the difference of 2 cubes. They messed up the signs. So when I plug in 2, I get 4 plus 4 plus 4, which is 12. All right, so let's do a little bit trickier stuff. Yeah.
Where'd you get the 2x in the middle of the...
It's just the formula. It's you multiply these two things together.
Okay.
All right, so rationalizing. So right now, think about it. Can you plug in 0? You get 0 over 0, right? So there has to be some kind of trick. So our trick for these ones is to multiply by the conjugate. So I'm going to do t squared plus 9, and then I'm going to do plus 3. And I do it on the top and the bottom. So I do a plus 3. So when I do that, I always leave the bottom factored, or the top if it was on the bottom originally. So I'm gonna go ahead and FOIL out the top, and then I'm gonna leave the bottom. Let me write my limit. I can't be a bad calc teacher. Do you guys get tired of writing limit, limit, limit? So I'm going to leave the bottom as t squared times the square root of t squared plus 9 plus 3. I don't want to multiply that t squared in. I'm just going to leave it like that because there's usually something that's going to reduce out. So if I FOIL the top, I'm going to take those 2 square roots and multiply them by each other. What do I get when I do that? T squared plus 9, right? No square root. And then my outer and inner will cancel. Do you guys remember why they cancel? Because I'm multiplying by the conjugate, right? So one will be plus 3 times the square root, and one will be minus 3 times the square root. So they'll go away. And then I have negative 3 times negative 3, which gives me negative 9. If you did this correctly, you will have your part that made it undefined go away. Do you guys see how I have t squared over t squared now? Can I do that in this step as well? So t squared and t squared will reduce out now. So I'm left with the limit as t goes to 0, and I have a 1 on top over the square root of t squared plus 9 plus 3. Am I able to plug in the 0 now?
Yeah.
Yeah, I can plug in the 0, right? So when I plug in the 0, I get 1 over the square root of 9, which is 3, plus 3. So 1 over 3 plus 3 is 1/6. Okay, I'm going to do these next two. So this next one, I'm going to multiply by the conjugate. I'll just set it up. And I leave this x minus 9 part as factored. Actually, maybe I should do this one. It's kind of tricky. So when I do that, I have the limit as x goes to 9. And I'm FOILing out the top. So when I FOIL out the top, do you guys see how you have x plus 7? What do I have on the end? Minus 16. Be very careful. Don't put 4. Some people assume it's under a square root. It's minus 16. And then I have x minus 9 times square root of x plus 7 plus 4. Do you see what happens? On the top, what do we have? X minus 9, they go away. So we now have a 1 on top. And then we have the square root of 9 plus 7, which is the square root of 16. So 4 plus 4, so we get 1/8. All right, I'm going to hold you like 1 minute into lunch. I know you want to cry when I do that, but I want to make sure you can do your homework. So this is the last one. All right, so sometimes you might have common denominators. So see how you have a complicated fraction within a fraction? This is just like Algebra 2. When we had fractions within fractions, we like simplified it, okay? So what I'm going to do is I'm going to multiply this first fraction by 4 over 4, and I'm going to multiply the second fraction by x plus 4 over x plus 4, so that I get common denominators. So I'm going to have the limit as x goes to -4 of x all over, and this bottom fraction, like fraction minus a fraction, is going to be 4 over 4 times x plus 4 minus x plus 4 over 4 times x plus 4. Notice how I wrote parentheses right here. This is very important that you put parentheses there because we're subtracting out that entire second fraction.
Fox.
Yes?
So for the other ones, you multiplied. Oh, wait, no, this is just a common one. Okay.
So I'm going to have x over, and when I combine those fractions on the bottom, I'm going to have 4 minus x minus 4. Do you guys see that? If you do this incorrectly on your test, you will get the opposite answer of what you want, because a lot of people forget to distribute that negative, or they won't know how it reduces out. Okay, so we have that. So the 4 minus 4 go away. So what we have is the limit as x goes to -4, and we have x divided by, let me write it with the old school division sign, divided by -x over 4 times x plus 4. So if I was simplifying that, I'm going to multiply by the reciprocal. So I'm going to have limit as x goes to -4, and I have x times the 4 times x plus 4 goes on top, and the -x goes on the bottom. That removes the part that made it undefined. It's removing the 0 over 0. Do you see it? So when we reduce, that goes away, this goes away, we're left with a -1. So what happens when you plug in -4? You do get 0, yeah, because the x plus 4 part. So we get 0 there. So sometimes your limits are 0. Don't be confused by that. All right, so let me pass out your homework. And then if you guys have homework for me, make sure I get that before you guys leave.